Great. Final example, show that x to the 6th minus 4x squared plus 7 is even, show that negative x to the 5th plus 2x cubed minus x is odd, and show that x plus 2 is neither. All right, first thing we want to do is we want to remind ourselves, what does it mean to be even? So to be even means that when we plug in the negative version of a number, a negative x, it's the same thing as if we'd plugged in the positive x. Doesn't have any effect. And the odd version, actually, let's put it in a different color so we can see how all the problems match up to each other. So if we do with the odd version, then if we plug in the negative of a number, it comes out to be the negative of if we'd plugged in the positive version of the number. All right, so first one, show that x to the 6th minus 4x squared plus 7 is even. So that was really seeing that as expression as if it were a function. So let's show this by showing that if we plug in negative x, it's the same thing as we plug in positive x. So on the left, we'll plug in negative x. So negative x gets plugged in, becomes negative x to the 6th minus 4. Plug in negative x squared plus 7 equals, if we plugged in just plain x, we'd have plain x to the 6th minus 4 plain x squared plus 7. Great. So negative x to the 6th, remember, negative times negative cancels out to positive. We've got a 6 up here, right? We're raising it to the 6th power, so we've got an even number of negatives, right? Negative and negative, cancel. Negative and negative, cancel. Negative and negative, cancel. That's a total of 6 negatives. They all cancel each other out. So we've actually got negative x to the 6th, the same thing if we just said x to the 6th. Minus 4, same thing here. Negative x times negative x cancels and just becomes plain x squared plus 7 equals x to the 6th minus 4x squared plus 7. Turns out that it has no effect. If we plug in a negative x, it's the same thing as if we plugged in the positive x. Plugging in a negative version of a number is the same thing as plugging in the positive version of a number. So checks out, it is even. Great. Next one, let's look at odd. Negative x to the 5th plus 2x cubed minus x is odd. So we'll do this the same sort of thing. We'll plug negative x's in on the left side. So negative x to the 5th plus 2 negative x cubed minus negative x. What's going to go on the right side? Well, remember, it's if we plug in the negative version of the number, then it's the negative of if we'd plugged in the positive version of the number. So it's negative of if we'd plugged in the positive version of the number. So plugging in the positive version of the number, that's just if we had the normal x going in. Negative x to the 5th plus 2x cubed minus x. All right. So negative x to the 5th. Well, what happens when we have negative x to the 5th? What happens to that negative? Negative, negative, cancel. Negative, cancel. Negative. That 5th one, because it's odd, gets left over. So we've got negative, and we can just pull that negative out. It's the same thing as negative x to the 5th. Plus 2, once again, odd. Negative, cancel. Left with one more negative. Total of 3 negatives, so we're left with a negative. So we get 2 negative x cubed. Minus, we can pull that negative out as well, negative x equals, let's distribute this negative, so we get distribute cancellation, negative shows up here, cancel, so we get positive x to the 5th minus 2x cubed plus x. So let's finish up this left side, do cancellations over here as well, positive, positive, this stays negative, positive, positive, so we get x to the 5th minus 2x cubed plus x equals the exact same thing over here on the right side. Checks out. Yes, it is odd. Great. Finally, let's show that x plus 2 is neither. So to be neither, we have to fail at being this and fail at being this. So to be neither, it needs to fail being odd and being even. So it needs to fail even and odd. So fail, even, and odd. So let's just try plugging in a number. Let's try plugging in, say, negative 2. So if we look at x equals negative 2, then that would get us negative 2 plus 2, which equals 0. Now what if we plugged in the flip of negative 2? We plugged in positive 2. X equals positive 2. We plug that into x plus 2, and we'll get 2 plus 2, which equals 4. Now notice, 0 is not equal to 4. We just failed being even up here because the negative number and the positive version of that number don't produce the same output. Plug in negative 2, you get 0. Plug in positive 2, you get 4. Totally different things. So we just failed to be even. Great. Next, we want to show that it's not odd. So odd was the property that if we plug in the negative, it's going to be equal to the negative of the positive one. So 0 is not equal to negative 4 either, right? If we plug in negative 2, we get 0. If we plug in positive 2, it turns out that that's not negative 0, just 0. It turns out that's 4. So we fail to be odd as well, because it isn't the case that if we plug in opposite positive negative numbers, we don't get opposite positive negative results, because 0 is not the opposite of negative 4. It is just the opposite of 0, so it fails there. So it checks out. That one is neither. Great. All right, cool. So we just learned a whole bunch of different properties, and they'll each come up in different places at different times. So just remember these, sort of keep them in the back of your mind. If you ever need a reminder, come back to this lesson, just refresh what that one meant, because they'll show up sort of in random places, but they're all really useful, and we'll see them a lot more as we start getting into calculus. Once you actually get to calculus, this stuff, especially the stuff at the beginning of this where we talked about increasing, decreasing, relative maximums, minimums, that stuff's going to become so important that you're going to understand why we're talking about so much right now in this course. All right. Hope you understood everything. Hope you enjoyed it, and we'll see you at Educator.com later. Bye.